or Evan or anyone else? Was anyone able to look at the programming labs? Were you able to access it and so on?
Christine is saying it worked for her.
Okay. I didn't look at any of the labs.
Okay, so just so you know, I mean, the labs will be slightly more involved. So please go to the labs and you will actually get to write actual code and write some unit tests and so on. Certainly, if those who are more advanced, you might like this kind of lab setup. Certainly, and also the lab for this time has some more interesting problems in there. Towards the end, I can review the material that is included. There should be a lab. There should be a lab for the last class, and there should be a lab for this one too. So if you go like on the course page, at the end, towards the end, if you look at session 4, you see there's 4. Okay, it's not ordered correctly. I'll fix the order. 4.4 has a lab in there. Can everyone see my screen? Or can you see my screen? Someone? Okay. Okay, so we should start, right, Manish?
Yes.
Okay, so quickly, let me just do a quick recap of last time. And this time, I will do a little bit more of the talking because there's a lot of information I want to get across to you. So,
I think अब मुझे जाना चाहिए. मेरी क्लास का टाइम हो गया. ठीक है. अगर ये WhatsApp नंबर है?
Sorry.
जी WhatsApp नहीं है. ठीक है.
Okay, sorry. So, okay. Just to get started, I would say, just to review from last time, right? So we covered functions. We covered how to use booleans and make branches using if else statements. And then we covered loops. So make sure that you all, some of you haven't looked at the labs. Please do make sure that you look at the labs and write code and just give me some feedback on the labs. This lab uses the ideas from these sections, but I think a little bit the focus on the lab, if I might just click to it quickly, the focus on this lab is to get all of you to write these tests and start thinking about writing unit tests and checking your code with unit tests, right? And that even if you're an advanced programmer, that can be a challenge to find the right set of tests. And it will be definitely very, very helpful if you are ever looking for, industrial strength jobs. I'm sure this question will come up at some point. How do you test your code and so on? So having experience with this, and I would say testing is an example of a topic where we could have big discussions. I don't think it's relevant to get too deep, but if a question occurs to you, we can discuss it and also send me an email or something to follow up. Okay, so please explore and come back to me with questions. I think there's plenty of very nice stuff here. Last time in the office hours, I talked a little bit about the logic behind some of this code. But again, that's a beautiful topic for office hours to say, okay, we want to test various kinds of things. What kind of options do we have? And here I've used a specific framework called unit test. There we can talk about other frameworks and various other options. So there's plenty to explore here. So go ahead and do it. Quickly, just for us all to get started, maybe a couple of polls. So can we just get you to click through these polls quickly? We are at the midway point in the course. How do you feel about all the topics we have discussed so far? I'm curious. So let me see. Okay, nobody has taken it. Can all of you click on the poll quickly? Oh, the poll, someone's asking where's the poll. Session 3 review, which would be kind of like under the overview section in session 4. So one thing I would love is, just please, I took a lot of effort to try to put the website in a way that you can follow along, not just the polls, but also look at the code and so on. So rather than putting everything in text and non-interactive, you should be able to kind of check things out as we go along. So I hope everyone's navigated here. Let me see if I got more responses. Okay, I got 6. There's more of you. Are you still finding your way to this page? take the other one too. So we kind of split, right? Comfortable. Some people need a little bit more practice. Okay, another important thing, I am definitely trying not to talk to the middle of the class. So if you're either very advanced or very early, just reach out to me and we'll schedule time during office hours or otherwise to make sure that both ends of the spectrum are covered, okay? Okay, let me see if I got any more responses. Okay, 11, okay, that's better. So more people who need practice. Okay, please, yeah. So this is like a midway point in the course. So I'm just taking a few extra minutes to talk about this. The biggest thing, the hardest thing to do is, I was watching a nice article on the neuroscience of learning, right? And the neuroscience of learning is that the brain creates these patterns that it recognizes, and it strengthens them. With by building protein around the pathways, okay? And so the patterns get strengthened and you can just use almost reflex to write your code. So this is a good time. I think things will feel challenging, but if you just keep doing it, I think you will just get very good at it. So give yourself the opportunity. I think, you know, being able to think in a structured way and write code will be useful in more ways than you can imagine. So please work through it right now, okay? And then the second poll, now that you've seen ideas relating testing and writing some tests, what is your opinion about testing? Okay. Let's just see what kind of responses we get there. Okay. Some people wanted to go away. Okay, again, that's a beautiful exchange for us, right? Because in the beginning, I felt this way too, because I was writing my program. But I want all of you who think that testing is a little painful to just reflect that when you write your code, are you sprinkling your code with a lot of print statements and looking at outputs along the way? If you are, then that's not a very efficient way to write code, because you have to then go in and delete the print statements, and you cannot automate the analysis of the output of the print statement. It requires you to read the output and decide everything is working properly. So again, this can become a bigger discussion. Please engage me, right? I think it's okay to say, make it go away, and then we can discuss where it can be useful and how you can tame it and make it more relevant to you. Okay, so now let's get into this section. Today we are transitioning from the world of logic a little bit into the world of data, right? And in particular into the world of data structures. And of course, I just put this quote in here which says there's no data science without data. And I don't mean to be facetious. I really mean that understanding, organizing, managing, manipulating data becomes a foundational element of anyone who wants to write code today and of course do data science, right? So we need to get very efficient. Hopefully today you will see that we have manufactured these data structures that help us to achieve many objectives quickly and efficiently. And you know, if you already see it, that's great, but there's no limit to how beautiful your code can become when you use the right data structure to do the right activity. Maybe I will show you a couple of them as we go along, okay? So today, first, I think the data structures I want to talk about are lists, tuples, and dictionaries. But before I do that, I want to just share with you this kind of thinking pattern. The first time you see it, it might be a little abstract. But I think this thinking pattern is, I synthesized this over years of playing with data structures. There's a simple way to look at data structures so that we can understand them quickly and efficiently. And that is to ask, what in one or two lines can I summarize the key properties of this data structure? And I give you an example. For example, a list is an ordered collection. There is a natural notion of order. A dictionary is not an ordered collection, for example, to compare the two. And a list can be changed. So it's mutable, right? And so on, right? So you can add more properties that you associate with a list. And when you look at a dictionary, you see the difference is it's not an ordered collection. So the index is not what we use. It's what is called an associative collection, right? It associates keys to values. So if you're doing a lot of, you know, give me a student ID, let me get his grade. Those are examples of associative lookups, right? So dictionaries are optimized to do this. And we'll write some code and so on to explore this today. So the first thing when you encounter a new data collection or you're reviewing or analyzing existing, just the simple ones we're going to talk about, make sure that you kind of like a mantra you can tell in 1 or 2 sentences, and then concentrate your attention into making sure that when you see a problem, you immediately know what's the right data structure to use. The second thing is that because these data structures are used so heavily, there are some intricate patterns to create them. So we look at creational patterns, right? What is the exact type of code I have to write to create this collection? Then you have to ask the question, how do I access elements of the collection? So for example, for a list, you can use a bracket, an index. I'll show you all this today, etc. Right? So how do I access elements? Then this is going to be a rather tricky operation, because these data structures are mutable, and if you make changes, the data will get lost. So very often in your code, you have to carefully copy the data before you make changes. And the question is then, what's a nice way to copy? And this can become a rather deep subject actually. But anyway, it's good to know how to make copies. Then how to iterate, right? How do I loop through all the elements if I want to do? That's a normal pattern. And then what operations, for example, can I sort the collection, etc. And lastly, you have to have a nice little toolbox of problems you've already solved using different data collections. And in this section today, I will try to give you all enough examples of doing this. Okay, so before we start, I just thought, so let me ask on chat, does everybody know what a magic 8-ball is? Or does anybody not know what it is? Everybody knows. Oh, many of you know. Okay, so the 8-ball is just a toy. You can shake it and it's supposed to give you an answer to a question you ask. I just wanted to include this here to say to you that it's easy to start writing programs, okay? But what we need, of course, is a little imagination of which problem to solve. By the end of this session, we will look at the code. By the way, the code is here, so those who are advanced can look at it. It's a very small piece of code. So let me just run the thing anyway. So you think of a question in your head. I'll give you 1 second or 3 seconds to think of a question. And then you ask the magic 8-ball. So I run it. It says, would you like help with the decision from the 8-ball? Press yes or no. So let's assume we want help with the decision. If you put yes, it says whatever you asked is saying don't do it. Okay, now think for another decision. If you hit yes, it says without a doubt. So the idea is that it produces different responses based on the question. And you can tweak this program. Why did I show you this? Just to say we can have a little fun. We can write complete programs, and then you can evolve these programs in many directions, right? You can make the user type in the input. You can make the user talk the input. There are many things that can be done fairly easily on top of this little structure. Okay, so much for that. So now let's go to the next section, which is really, I want to start off the class and start talking about lists. So as I said, so I will follow this pattern. I will try to answer all of those questions. So somebody asked, are the answers? Yeah, the answers are random. So there is a small section today where I will talk about randomness. Okay, very interesting topic. If I skip over it or whatever, just remind me, make sure that I get to talk about random, okay? I will try to monitor chat, but please don't hesitate. You can turn on your microphone and interrupt me. No problem at all. Okay, so to recap, I said a list is mutable ordered collection, right? So let's explore the mutability, the orderedness, etc. But of course, before I do anything, I have to create a list. So the nice thing is, so now I want, also please remind me to adjust the font if it's small. But okay, so the nice thing about a list or any collection is, because we use them so much, there will always be a special smart way to create a list or a collection. And for a list, it's a square bracket. Just to contrast quickly, for a dictionary, it's the, shall we call it the curly bracket, right? So, or the flower bracket, as some people like to call it, right? So there's always a quick pattern. We've already seen one pattern. By the way, strings are also collections. That's why you surround the string with a quote, right? So there's always a creational pattern of this kind. So that's fine. So I can create a list. Then
Sorry to interrupt.
Yes.
I'm asking on behalf of beginners that why would we need a list when we have atomic variables?
Yes, actually, it's a good question, Manish. Why don't I turn it over to the class? Can someone unmute yourself and talk for a minute about why you would use a list? Maybe some of the more advanced people in the class. Andrew, maybe? Evan? Okay, anyone? Oh, you want to repeat the question? No, the question is, why would you use a list instead of creating multiple variables? For example, I could have created a variable A, B, and C and stored the values 1, 2, and 3. Why would I create a list? I'm watching chat as well. Lists are more convenient. Okay. Convenient in what way though? Faster. Faster.
Basically, list summarizes all the things in one way, and in multiple variables, we have to go one by one in every pattern.
Yeah, so I'm going to say, of course, there's a little grain of truth in what everyone is saying, right? Which is, it is more convenient, but the convenience is that I don't have to litter my code with many variables. That is definitely a convenience. But I think the bigger convenience and the bigger importance is that the list is growable. So if I need to have more values, I don't have to create more variables. And remember, this code is running. This code is running in production. So then you cannot go and add variables, right? So what do you do in that case? You make a list, and as the user provides data or as you read a file, you can grow the list, right? So this growability is a key feature. Speed is a whole discussion. How fast does the code execute accessing lists versus variables? And this becomes a very technical subject. So please prompt me later and we talk about speed of accessing elements in a data structure. Okay, but Manish, hopefully I covered some elements. We all, including the chat and my comments, we talked about some of the reasons why we would use lists. Yeah.
Yes.
Okay. Okay. So like Manish did, and all of you, please feel free to interrupt. And of course, if you're more comfortable with chat, just go ahead and try to type there. I may not process everything, but I will keep an eye on the chat window. Okay, so what am I doing now? So now I'm saying that once you do make a list, you can of course check the type of the list. So let me just run this code. You'll see the output. The output from line 7, where I ask you to print the type of the list, it clearly says it's a class, it's list. Now I want to show you that there are, and this becomes like a small intricate set of patterns. There are patterns that allow you to create lists quickly. And I think at least you should learn this simple pattern, which I found very useful. Especially you'll find it useful when you're writing, practice code. If you want to create a list of 10 elements, the list constructor is powerful. So if you give it something that's iterable, something that has many elements in it, like a range, it will iterate through the range, pull out all the values and make a list for you. So look at this pattern and internalize this pattern. When I first found this pattern, it saved me a lot of typing, because otherwise, if I want to create this list 0, 1, 2, 3, 4, 5, 6, 7, 8, I would have to type out a lot of values. Here I can do it with one instruction. And if you're a master at ranges, you can skip over alternate variables or go backwards and create all kinds of lists to practice with. So make sure you master this pattern. It's a nice pattern. But the pattern doesn't stop there. The list constructor is clever. If you give it another kind of container, for example, if you give it a string, it will automatically split the list into letters, if you see here, and then make a list for you, right? So these little patterns, and this is what I said for those who are advanced, if you make a discussion, I can introduce you to more of these kind of little powerful, almost Jedi patterns, right? If you have to split this thing, you might call some other method, but this is very easy to do once you know that this is possible. And then the last thing is, of course, when you create lists, you can make nested lists. So you can put lists inside lists. Okay. So I've summarized the creational patterns here, right? So make sure you do that, and it becomes kind of routine. Either you use the square brackets, you call the constructor function, or you can call a function that creates and returns a list. So this will happen in many places in our code where we can call a function that can create and return a list.
Vijay, okay. Please increase the font size.
Okay. Is this better?
No, in the code.
Oh, in the code window. Okay, yes, sure. Okay. Yeah, that is something right now, it's a separate operation. So hopefully I do it routinely. Okay, so I'm going to spend a little time on this page. So I guess we don't need the whole window to be increased. So now the next question is, how do I access and modify elements of a list? Okay, and this is where we said, we must master the patterns, and the list was created. So if I say A equals 1, 2, 3, then the list was created with the intention that you can just use a square bracket and specify an index to access an element of a list. But now comes the first, I put it here as a programming tip, the first kind of mild problem for people either switching from different languages and or from the ordinary world into the world of Python. What index would you assume for the first element in this list? I go through this painfully because some of you are seeing it for the first time. What is the index? Okay. So the index for the first element in the list would be 0, not 1. And this causes a lot of friction for us. Why a lot of friction? Because I want you to get, if I ask you, get me the first element from the list, you have to type 0, even though you heard the word first. Okay. And over time, I think all Python programmers will just do this in their sleep. And those who are seeing it first time, it can be a source of bugs. So try to pay some attention and just pick it up. Okay. Now, I have a lot of things to show you, so I will just talk you through this. So we covered this idea of using indexes, right? So the main point with index was that it has to be a number. It starts with 0 and goes up to, okay, what is the maximum value? If a list has length L, so let me type here. If a list has length N, let's say, what is the, what is the maximum? Okay, let me make it a number. If a list has length 5, what is the maximum value I can use for the index?
0 to 4 it will be.
Yeah. So the maximum value is 4, right? 1 less than maximum. But is there a sense in which I can go negative values? Does anyone think that negative list, so for a can I say A of -1? Would that make sense? From right to left. Yes. Yeah, somebody said in chat, yes, it makes sense. It goes in the reverse order, right? So let's just make sure that all of you get familiar with this thing. Sometimes you need to access in reverse order, so negative values can be helpful. Okay. By the way, for all of you, just to run any demo that I have put in the demo page, first of all, let me introduce one idea quickly, and then we'll revisit this multiple times during the session. If I have 2 files in my program and I want to use the code that's sitting in another file, then I can just import it. I say import the file name. I don't need the .py. We can talk about files and modules later, but think of it as file for now, it's okay. So everything from that file is brought in, and then I can store it under a namespace or a value D. And then if I want to access anything from that file, I have to do D dot, and then I can access it. As soon as I put D dot, it's as though I'm writing code inside that file or accessing code inside that file. So I have written all the code because it gets a little cluttered. I want to run each demo one by one. So I've written a little code that will do that. So for example, if you want to see what happens when we run the demo 0, you just go here and you put in the value 0 and you run it. Okay. And you should be able to see the output. Okay. So it's a nice little way. For those who are advanced, you can figure out how that actually works. And if you have a question, you can ask me. Okay. Okay. So the next question here is, if I take a list, I index. So I want to modify. So how do I modify elements in the list? That's the main thing we're exploring here. The obvious thing is you can access a value by using the index. But now if I use the indexed access on the left-hand side and use an assignment statement on the right-hand side, it will update and the list will get modified, right? So for example, if you look at it here, let's run, let me just pick up the demo number. So this is demo 1. So if you pick up this, you should see that the same list we have created is now getting modified and the first element has changed its value. Okay, so this is why I said the list is mutable. Okay, so the list is changing in some way, but notice that when I created the list, I gave it some label L1 or whatever here, so I'm passing L1 into this list and we have to start asking questions about what is exactly happening. I'll show you some detailed demos of when I mutate a list, what actually happens. Okay, and when I make an assignment to a list, what happens? Or when I pass a list to a function, what happens? Give me a minute and I will get there. Okay. The next thing, I don't know whether I want to do much talking about this, but I would urge all of you to spend some time playing with this. This will be very important for you when you work on data science, when you work on things like pandas and so on. This pattern, actually, I first played with this pattern a lot inside pandas. And then I went back and said, does Python lists, because I wasn't using, this is called slicing. It allows me to get subsets of elements from a list out. And
so I just need to interrupt you. I want to ask one question over here. Suppose if we create list L1 equals to, in bracket and square bracket, 1, 2, 3, in ascending order. So the index of that particular list is will be start from 0 to 4. It would be 0 to 3. Is that correct? Yeah. But if we suppose change the order of the list, suppose we will start our list from 4 to 4, 3, 2, 1. Does it make sense that it would change the index also of that particular list L1? I'm not creating L2 over here. I'm just changing the numbers.
Okay, so I already have.
Or the index.
One second. Let me see if I understand your question quickly. So if you're saying if I have created 1, 2, 3, you want 4 also, I can put 4 in there.
1, 2, 3, 4. Yeah.
So I got this list, and now you want to reverse the order by hand.
Yeah, just
by making a new assignment. Yeah. So what is the question?
I'm asking over here is that does it also change the index of that, or it would only start from 0, 1,
no,
2?
So notice there's in language where here the Python programmer and the English language allows us to be very precise. There is a language here which says what is the index and what is the value. And the index here in this example, it's mildly interesting. 1, 2, 3, 4 are values. The actual index here is 0, 1, 2, 3, right?
Yes. 0, 1, 2, 3.
There's a distinction. First of all, there's a distinction in language between the index and the value, right? So these are the indexes.
Okay.
And these are the values. Yeah, I'm just writing them side by side.
Does this index? Does this?
1 second. Let me finish.
Same for the other one also, in which we have changed the order.
1 second. Let me finish. So the important point here is that if you change the order, you do not change the indexes. The indexes are always God given. It's an ordered collection, and the index is always going to start from 0 and end with the length of the list minus 1. Okay. So it's a very precise thing that we have to get into our minds and lock it down once and for all. There are two different worlds. They have nothing to do with each other. The values and the indexes completely different, right? And values here in this example, the values are actually integers, but they don't have to be, right? They could be any kind of values. They could be floating points. They could be anything. But integers have to be used for indexes. Okay, so even though this example kind of suggests that they are kind of similar in some sense, they are not at all. There's nothing to do with. It's like one world and another world. So we should never have any confusion between the indexer and the value. Does that answer your question? Sorry, did I answer your question? Okay, I didn't hear it, but anyway, I think
yes, sir. Thank you.
Yeah, the question made me just repeat something that may help all of you in our language, and even when I'm talking today. Let's make sure that I make no ambiguity between the value and the index. Okay, so that's really useful and important for us to make sure that we master that. Okay, let's go back to demos. So now I was talking about slices. So let me just quickly tell you about slices, and then it's a question of experimentation. So a slice, if I look at this example, a slice is a subset of a list, and it has a pattern here, which is very similar to how we create ranges. There's a start value, a stop value, and a step value. So this start, stop, step pattern is a nice pattern for us to kind of internalize. It's useful for ranges, and it's useful for subsetting, right? So please play with the start, stop, step values and access subsets of a list and make sure that you understand it. Understanding, okay, so now, so that's as much as I want to say for slices right now. If you ever need subsets of a list, and you will see as you write more code, very often you need subsets of lists. This is a nice way to access subsets. Now, the other thing with start, stop, and step is they're all of them are optional, right? So for example, you could just leave the step out and it will work. Okay, so please play with this idea too. You don't have to always put in the start, stop, and step. And I leave it to you to decide in a coding style, do you always want to write down the start, stop, and step values, or you just want to write down the ones that you want to use? For example, if you can always say, I want to start from 0, or I want to start from 1. If I want to start from 0, I don't have to specify it. So please play with these, right? Delete some value, make sure the default does the right thing. I think there are far too many combinations for me to talk about, but I create the picture in your mind and just write a few lines of code and it will become second nature to you. The other thing is we briefly talked about negative indexes, and the negative index, of course, just to repeat, if it goes in the backward direction. So it's -1 is the last element, -2, -3, -4. In a first pass, I don't know if you spend too much time thinking about negative things, but there are moments, and it's a standard interview question, reverse a list quickly, and then you can use this pattern to reverse a list quickly. Okay, so now this is an important one, this demo here of assignment does not make copies, but I will give you a rather detailed visualization of this. Okay, so just hold on to this particular idea of what is the idea of making copies. The other one here is that this is a very important idea. So let me see if I can get this across to you. A list, I said it's a mutable collection of values, but I didn't say the values have to be of the same type. Right? And for those who come from C and so on, in some languages, you have to declare this to be an array of integers. Then you cannot put any other kind of type in it. But in Python, it's really an array of arbitrary type. And so you can put integers, strings, and floats and all kinds of things in it. And beginning programmers will abuse or use this feature a lot, right? But I want to now stress to you that if you do put a lot of different types into a list, even though Python won't break, you as a programmer will have trouble, because when you extract elements out of the list and you try to perform some operation on them, you have to first check what is the type of the element. And so that makes your code very, very messy. In fact, in Python, you don't want to keep thinking about the type of objects. So if you put only integers in a list, you can pretend they're integers. So you can add all of them and so on. It makes sense. But if you put strings in there, you try to add all of them, then adding an integer to a string doesn't make sense. Sometimes it will break, sometimes it will do random things. So a guideline is, even though the list allows multiple types in it, try not to put unrelated types into the list. That's just a suggestion from me. Again, this can be a bigger discussion. It leads to all kinds of beautiful patterns about how we put things into lists and extract them and use them, etc. This is not something that typical books emphasize. I'm going out of my way to emphasize it because I think in the long run, you will see that if the elements of a list do not have a nice relationship, I'll actually say for those who are advanced, if they are not subtypes of things in a certain sensible way, then putting them together will make your code a little bit hard to manage. Now, if you're just using it for storage, you just read it and you dump it or something, it doesn't matter. But if you're going to do anything with it, better to have kind of related types in a list. Okay, now what operations can we do? So the first operation is how do you join lists? And you can see as soon as I show you this, this is where the kind of next level of proficiency, right? That there are shortcuts and nice things all over the place. So for example, for a list, if you just do plus is the operation concatenation, right? It takes two lists and adds all the elements of the second list at the end of the first list. So if you run, let me run demo 5 quickly. So let's see, the list L1 is 1, 2, 3, 4, 5. The list L2 is supposed to be a copy or is a reference to L1. We'll come to this equal to in a second. And then I can just add them, right? So if I run demo 5, we will be able to see that I will get a list. They should have just 2 copies of the same, sorry. Okay, I have to see what's going on here. Did I just leave it out? Okay, I'll come back and debug this. I don't know. Okay, so you can just run it directly. Okay, so I can say demo 5 like this. Oops, I'm sorry. Hopefully, unless there's a bug in the code itself. Okay, so you can see this. There are 2 copies of the list here, right? Because we did the plus operation. So, okay. So that's how we can add two lists. Just this is a little tedious, so I don't really need to talk through every line, but I'll kind of do a quick walkthrough here. So these patterns should just go into your memory. So maybe you can just erase this code and just go through them one by one and just do it yourself. And if you do this a couple of times, it'll be second nature, right? So if I want to append, so this is plus the concatenation is one way to join two lists together. You can also add single elements by using append. You can also use extend. Okay, so please play with append, extend, and plus, and just look at different ways to use these operations. Then you might want to do a nice operation, which is go to a specific location and insert a value. And you can do that by using the insert function. Okay. Any of these demos, if you want me to run it, just let me know. Okay, I'm going to skip through them because if I just talk through the code, mostly you can see what is going on. So we know now how to append, we know how to insert. The next thing is how to delete elements. And there's this del pattern you can use. But of course, before you go to delete something from a list, this is important. When you go to delete something from a list, you must first ask the question, do I want to delete by index or by value? And sometimes you might want to say, find the value 23, no matter which index it is, and delete that. And sometimes you might want to say, I want to delete the second element of a list. So here, if you want to delete by index, list is very friendly to you in terms of doing stuff. So you can just index it and call del. You can also deal with slices. Okay, so you play around with the del operation. How to remove something by value is interesting. So there are functions for it as well. So you can call this function called remove. Okay, so please notice the distinction I made between removing by index and removing by value. Okay, and you need a different pattern to do it. And then there's this pattern for nested lists. And the most important part of this pattern is to ask the question, how can I get into, so for example, here is an example, student grades. I have a list. Inside this list, I have another list. So for example, if I want to extract a particular element which is inside that list, then you start to use multiple indexes. So for example, you say student grades here, and then you use a bracket. In this bracket, if I say 0, I'll get the first list. If I say 1, I will get the second list. So notice nested indexing can get a little messy. So let me take the first element. Now inside the first element, if I want to get to the grade itself, then I have to put one more bracket here, and then it'll be 0, 1, 2, 3. So sorry, 0, 1, 2. So I have to put this. Okay, so write a small example like this and see if you can use nested indices. It is a very standard pattern to make lists of lists. In fact, it is also a mathematical pattern because that's how we store matrices, for example. And so this multi-index, at least 2 indexes, is a very common pattern because those are 2-dimensional arrays. So please take a pencil, draw out a couple of 2-dimensional arrays, initialize them with numbers, try to extract different values, different subsets. This will be a very helpful exercise as soon as we get to data science. And all of these patterns will translate to other libraries like pandas and numpy. So you'll be in a great place to start off and very familiar with all these ideas. When I first started to do some of those libraries, I just ended up going back to Python and mastering all these patterns. So please, it's a little tedious, but maybe you'll find a way to look at it as fun. Let me pause as I'm changing pages. Any quick questions here? I'm looking at chat. So yes, no. Questions? At least somebody should say no questions or no. Nope. Okay. Okay. So now I want to come to a very tricky thing. Okay. And I think the best way for us to understand this may be just this visualization. So what is the tricky thing? Whenever we have objects that have state in them, like a list has a certain amount of state, this is a basic thing I'm going to say, but it's a very profound aspect of programming. Whenever we store state in some place in our program, and then in some other place in our program, we modify the state, we have to be extremely careful about what is going on. And by careful, I mean, we have to ask the question whether you want the state everywhere to be modified, or you want a copy to be made and a copy to be modified. And understanding this pattern very clearly when you write your code and making it second nature will really take you from a level 0 to a level 1 programmer just overnight, if you can see this everywhere. So let me show you why this seems like a simple idea. Why is this difficult? So in this demo, I create a list. So you can see if you look inside the mind of Python. So first of all, let's just look at this for a minute. I think this visualization is worth a lot. At least for me, when I first visualized it, it was very useful. So there's a global frame, there's a variable L for the list, and it points to this collection, right? So the collection gets created in memory, and the label knows how to find that collection's pointed, is associated to this. Now I wrote a function here, right? And in this function, I basically said, pass me a list. I'm going to say L1 equals to L. So I think that I'm making a copy and storing it in L1. And this is the source of the bug, but let's just see what actually happens. So I use assignment and I say, look, I made a copy. Now L1 will have all the elements as the list. So if I run through this code now, sorry, of course, it just defined the function. I'm going to invoke the function now. So if I run through this code, you see this change list gets invoked by passing L into it. So that's what this extra arrow shows. L is coming in right now. And now I'll go to the line that I want to look at, which is where I thought I was going to make a copy. And you see L1, which is inside this list function, L1 is also pointing to L. So I said that easily, but that is very, very important. If I do equal to and think I made a copy, I didn't make a copy. They're all pointing at the same place. And so now if I change L1, thinking that I changed my copy, then you see the original list gets modified. And so this is why I said this is a source of bugs, right? Because you thought that you made a copy and you're modifying stuff. Then when you come out of your function, your original list has gotten modified unintentionally. And that could be a bug. Now, if intentionally you wanted to modify it, that's a different discussion. But there is a discussion for the advanced programmer. Should a function which is being passed a parameter be allowed to modify a variable that lives outside the function? And we could spend at least half an hour talking about this pattern. In general, I would say after many years of programming, you will come to a conclusion, which I can share with you right now. It may not make enough sense. Functions should only modify things that are local to them, and they should return values. Functions should not modify things that are living outside them. If you do this, it will make your function encapsulated and your code easier to reason about. Things will not get changed all over the place when you run a function. If you don't do this, your code after some time will be very difficult for you to manage. Okay, little bit advanced. I don't know if all of you get it. If any of you get what I said and whether my comments made sense, do tell me in chat. I'll give you 10 seconds. Did my comments make sense? I'm trying to overemphasize an important point. Anyone? Okay, couple of you at least. Okay, so yeah, like I said, it'll save you a tremendous amount of pain later. Okay, so please run through this demo, put this picture in your head, and always be clear when you need a copy and when you are modifying the original thing. This equal to is so easy. I have myself written many bugs before I eliminated it. So now I don't make this problem anymore, but please, as a beginner, this is useful. Okay, so let me just print it. So therefore, you can see I modified my list unintentionally. Now, what is a way? Okay, if we don't want to do this, what is a way to make a copy, right? So there are many ways to make a copy. One way mildly recommended is to just call the list constructor here. So you see, it's a small change to the code. It's still an equal to statement, but I pass the original list or the incoming list to the list constructor. And the list constructor says, you've given me a list and you're calling me, I will make a copy for you. So let's look at this. So if you go in here and call this function, of course, it comes in, L is pointing at the list. Now this list has already been modified by the previous function. But as soon as you call the next line, let's see what happens. You see L1 gets created and a new list has been made for you. And now if you modify this new list, when you come out of this function, you know, the old list is not getting tweaked at all. Okay, so the new list can be modified separately of the old list. Please write some code, play with this, make this pattern part of your story. Okay, so that's all I wanted to say here. Later you can tell me if this pattern is discussing this pattern was helpful. Now I just want to say something for those who are mildly advanced. Please look at this code. I won't run it. I'll just point out an important thing. There is a way, just like this visualization showed you that there were different locations in memory where the data was stored. And if you want to check exactly are they pointing at the same thing or different things, there's a nice little function here called ID, right? So let me just run this code, first part of the code. You can see this. See, I can actually look at the memory location. And it says the memory location is the same for the two of the lists, because I copied one list to the other by making L2 equals L1 here. Sorry, the font is small. Yeah, sorry. Okay, so here I said L2 equals L1. And now if I use the ID function here, it will show me that the two lists are the same. Now you don't need to use this ID all over the place. I just want, for those who are a little advanced, it's a nice way to look at the internals if you're not going to create visualizations like this. Okay. Hopefully little heavy, but hopefully that's the rest of it is kind of going to be easy for us. So now the next question is, what are basic operations? So I'm going to talk about the operations more than actually writing any code. It's not very profound code here, but simple operations. So you should have this little catalog. By the way, there's a cheat sheet on a web page when I try to summarize this. So later I can show it to you, but if you explore, you'll see on the right-hand side of the web page, there's a small cheat sheet where I put all these operations together. So the next thing is, can I count how many times a particular value occurs? Can I find the index at which a particular value, remember this is access by value, the index at which a value resides? Can I sort a list? Can I reverse a list? Okay, so there is at least like the 15 methods on a list. If you want an exhaustive thing, I can point you to the Python documentation, but at least get familiar with these three different operations. Okay, and I have made some demos for this. Let me quickly ask, do you want me to talk through the code here, or you guys are going to just look at it and it's fairly easy? Someone? I'm looking at chat. Yes would mean you want me to talk about it. No would mean, yeah, do you want me to go through this code and talk about how these functions work or not? Okay, so at least one person says yes. Can I get one more yes? Okay, so there's a couple of yeses. Okay, good. Okay, so let me go through it quickly. Okay, again, if anything is going fast, just slow me down. Okay, I'm trying to, for those who are advanced, please start typing and run this code and, you know, start playing with it. You don't have to just wait to listen to everything that I'm saying. Okay, so for those who are advanced, just go ahead and write your own code, and, you know, we'll catch up again as soon as I finish this section. Okay, so the first part of this demo is you create a list. And of course, you can do all kinds of interesting things. I will introduce you to a nice little function. There is a section on strings that I will cover next time. But for today, I will just tell you a nice function. I think there's one of the labs that uses this idea too. If I have a string which has multiple words in it, and I want to take each word and make a list out of it, then I can just write the string and call dot split on it. And dot split will split it into separate words and make a list for us in one line, right? So if I just take this and put it here, for example, and just run it, let's just look at it. This is a interesting, nice pattern. I have actually used this pattern to give you a small lab assignment to analyze a piece of text. So this little split function is kind of a nice little function that you can use. You see, I can make lists out of it, right? The second one is coming from my demo. Okay, so so you see that it has taken the list, split it up into words, and then you have each of the words stored as an element of a list. So it's another of those pretty things. You can do it in one line. I don't know how you've done it in other languages, but sometimes people write loops and all this stuff, and these one-liners are very powerful. The one thing I will say now, and then we can explore this later, split makes an assumption. How can I split this string? And the assumption it's making is that I will split the string using the spaces between words. Okay, then if you had commas and the words were separated by commas, not spaces, split is clever enough to deal with some of those. But it's a big subject, how to break an object into substructures. But for now, I won't get into it. I just say use split if you want to just break a list. Okay. Okay. So the next one is, once you have created a list, you can just, if I want to find the index. So I'm going to talk through this code. If you need me to run anything, just tell me to run demo 005 or whatever on chat. I am watching it. So I use the index function. And I have to pass, so we'll make this a pattern. The index function takes values. So here play is a value that is stored inside the list. If I pass a value to the list, then index will find the location. Okay, and it will tell me which location. So the word play is located here. You can see in this output here. So it will actually find the index of this. So please write some code and just get familiar with finding. You can do it in your head, find the index. And then also this thing was created specifically to have some questionable things. For example, lists is repeated. So if I ask for index, what will it do? And the answer is obvious, it picks the first one. So if you have multiple entries in a list, you have to manage it by some further effort, okay? And the further effort is that you can ask it to start looking for something with a starting index and so on. Slightly more advanced, but at least start thinking of index, okay? The next one is to sort things, okay? And to sort things, there's this function called sorted, okay? And sorted is nice because it works not only on lists, it works on dictionaries too. So you can just pass a collection to sort it, and it will sort the collection. Now, sorting is a whole chapter as an algorithm, but here we can just use it as a function. The only thing I want to share with you is sorting makes assumptions about what to sort by. And the natural assumption here is delicate. For example, if I ask you to sort a list, what should I sort by? Should I sort alphabetically, or should I sort by the length of the words that are in the list? And sometimes you want to sort by the length, and sometimes you want to sort alphabetically, right? So sorted makes assumptions. You go and run it and figure out which, maybe that's a nice quiz question for you. Which criteria does sorted use by default? If you're interested, and or at some later point in the course, I will show you how we can change the default behavior and sort by any kind of function that you want to use. But today that will be advanced, okay? But I want to show you one more feature of sorted, which is what if I want to sort not ascending order, which is with the default, but I want to sort by descending order. So then it has a keyword. We talked about function keywords last time. So you can say reverse is true, right? And you can sort by reverse order. Okay, so sorted is a powerful function. Those who are advanced can spend some time reading more about sorted, but please come back and remind me to talk about how can I sort a list. Maybe I'll do it in the section on strings, okay? But in the meantime, if you want to know it sooner or whatever, I will talk about how can I change the default sorting behavior. But now we have just learned something very cool. We didn't learn the algorithm for sorting, but we learned how to use a library method that will get us sorting pretty easily. And you will see later that it's a very heavily used behavior. Okay, there's another one here. The list itself has a method attached to it called sort, and it will sort. Okay, so now one question we have to ask, and these are the kind of delicate advanced questions, right? When you mutate a list, sorting is mutating the list. Okay, take a moment and think about that carefully. Does sorting change the list or not change the list? And if you think about it as a pattern, you could come up with two different design requirements. If I sort a list, you should always sort it and put it in a new list. Or you can say, if I sort a list, I want you to modify the current list. And that again is a source of huge bugs. So you can see how mutation has to be actively managed. It's very easy to say sort, but then you have to be clear. Do I want to sort in place, or do I want to sort a copy? Sort and create a copy, right? So again, when you write this code, please keep the mutability in mind. Like when I do sorted here, the easiest way to do this is do the operation, change a value, print out the original list and the new list, and see which one is changing. Okay. Now, maybe I'll leave that as a small exercise. I want that for those who are advanced, start writing this code now and you can check it. Okay. I'd love you to turn on your microphone and I can hear all your keyboard pounding going on. But there's a difference in behavior here. For example, I've given you the answer here. If you call sort, it actually returns none and sorts the list in place. So sometimes you don't want to modify the original list because it came with a sensible order. So if you call sort on it like this, then you modify the list. So you better copy before and then call sort or whatever. So there's patterns that have to be used. Okay, and sorted simply says, I will make a new copy for you. So I will not allow you to mutate the existing list. So these, like I said, it's hard for me to lecture about it or talk about it, but having a natural mindset that asks the question, am I sorting in place or not in place? That question is in the back of your head when you're writing your code, and you know how to do both types of behaviors, make you very powerful and proficient in coding as well. And sometimes the reason why our code works is because we are not asking those questions in a sequence. Do I copy first? Do I sort first? Like, the sequence has to be the right one for your problem. And if you don't ask those questions as you're typing your code, then all kinds of bugs can happen. So again, I cannot teach in words, but just writing a lot of code. Okay, so hopefully I'm giving you the motivation to go and write a lot of code. Okay, so the next one is easy, just reverse. And the last one is tests of membership. Now, tests of membership, again, is very cool, right? Because in the old days, I remember when I was writing in C and all that, if you want to check a values in a list, I have to iterate through the list and compare with every value in the list. Okay, which is in order n if the list is n operation, but still I have to go through the whole list. But now you have simple methods in Python where you can say, check if a value is in L1 and print it out and so on. Okay, so please go ahead and play with this. Again, right now it's just theoretical. When we start writing programs, then you'll find all this very useful. If this is all in your toolkit, you're going to start churning out some really powerful programs very quickly. Quickly, again, I'll go to chat. Any questions on this? Or I have to watch chat carefully and see if a response comes in. Can somebody say yes, no, maybe? Any questions? Maybe I'm not seeing it. I have to scroll in chat or something. All good. Okay. Okay. So now we have covered some things, right? How to create a list. Then we have talked about mutability when you assign values and how to make copies and so on. We've talked about many operations on lists. And now we come to the next pattern, which is on a collection. How can I iterate through a collection? Okay. And this pattern also is kind of useful if you have a list. So let me talk through this. The first one is we already learned a for loop, right? So you can use a for loop. You can use, so let me just, I don't think I need this. So let me just take this off for a second. So you see here is a list. I have created a list. I've used the range function to create this list. So now you can go through this list using a for. So remember when we learned the for loop, normally we were using a range. And it was a big step in programming when people realized that for loops don't necessarily just have to work over an index, over an integer. You can work over any collection where the implicit meaning of iterating over the collection is go through all elements in the collection. So the idea here now is we should think later. I can talk to you about how does that magic work, because it's a very nice programming pattern. But the general idea here is whatever sitting in the location L1 here should be iterable or should produce a sequence which is iterable, right? If that is the case, then the for will work correctly. And for those who are advanced, you can ask this question, how can I make my own iterables? If I want to create a different kind of collection, can I make it iterable? And the answer is yes, and I can show you, but it's a little advanced, okay? So right now we'll use all the iterables that are in the libraries for us, okay? So if you say for element in L1, it will go through all the elements in L1 and just print it. So if you run it, you can see here, I've printed it out 10, 20, 30, 40. So again, all of you, there's no point me running the code, but either now or later, just tweak the code and see. And make sure that you understand that this, when you do this for, it pulls out the value and stores it in a temporary variable. And again, now there's an important idea to this pattern. This variable does not contain the index. I repeat, this variable element does not contain the index. It contains the value. And the reason it has been done this way is very often when you iterate over a list, you're iterating over a list because you need to have access to the values. So this pattern is nice and natural. But there are cases where you want to have the index and the value. In which case, there's a nice little pattern here again. You use this function called enumerate. And enumerate will return the index and the value to you, right? So I mean, all of you should be running this code and playing with it. You can store, please note, I had a little trouble remembering in what order it comes. So maybe when you learn it, if you learn it correctly, is the first value the index and the second value the value? or the other way around. And the first value is the index. So give it a nice name that allows you to remember clearly it's the index, and get used to this call in the value that order. Once you have access to this, then you can write a program to do whatever you want. Here I just printed it out. So you can see here, you can see the index and the values. Again, it's a very, as we talked about earlier, there's a clear demarcation between indexes and values, of course, which enumerate understands and allows us to work with, okay? And the last way to iterate, this is a very functional programming, modern way of thinking about it. This idea says, this is called a list comprehension. And this idea says that when you want to iterate over lists, maybe you want to create another list, okay? But what you want to do when you iterate over a list is to apply some kind of function onto the elements of the list. So please note, this is very powerful, right? Here I wanted to print all the elements in a list. And what I did here is I said for I in L1, and then here I can do any kind of function on this. So here I did the function print, but you could have used any function you want on this, on each element of the list. So notice that is now being elevated to a pattern. What is the pattern? Put data in a list, later loop through the list, pull out each element and do something to it. And I'm saying that there are at least three ways. One is using the for or the for with the enumerate. Another one is to use the list comprehension. And then the last one is to use map, okay? So there's a function called map. And notice something very cool when you do map. This is a very powerful programming idea. Again, if you want to discuss, we can explore. This is called actually a functor. But anyway, I will ignore my comment. For those who understand that, you can we can have a bigger discussion. I only say it to suggest that for every simple thing, there is slightly more advanced discussions that are possible. But for those who are working at an entry level, you don't need to get too deep into it. But what is special about map? What is passing a function as first parameter? And this is the first time that we have this idea of passing a function to another function. So long we passed, values and data and other things to functions. Now we are passing a function to function. So it's a function. But give me a function, I will be responsible to go through the list, pull every element out of the list, apply the function to it, and give you a new list. Okay. So you can, again, just make sure you do this. Make sure you run this code and write your own code, etc. I cannot stress, and I will pause for a second and ask Amit for a comment. I cannot stress how important this pattern is, because there's like major chunks of our code that reside in and around this pattern. But I will pause quickly and ask Amit, do you think that lists and iterations is a very standard pattern heavily used?
Yes. So
you want
there
to
are
elaborate?
languages where list is the only data structure.
Yes. Yes, yes. Where list is the data structure that we're using. I think this pattern is very heavily used. Yeah. In a way, you can ask rhetorically the question, why did I put something in a list only to take it out and do something to it? And so it makes sense that this pattern is there. What I cannot stress for you is how heavily this is used. So later, when you start writing a lot of your code, you can go back and ask, how many times did I use this pattern? And I'm curious also to for you to come up with guidelines. When do I use a for? When do I use a list comprehension? And when do I use map? Okay, so there are some reasons, but it's slightly advanced. So you can come back and we can discuss it. Okay, so much. I've exhausted iteration now. We talked about imports. Okay. So I would just let you internalize just this simple idea, right? Okay, again, I'll make the font larger. Internalize the idea that when you want to import behavior, whether it is living in a file that you have created like this, or whether it is in a Python library. So today I'm showing you how to get some Jedi powers. Later we will start using random. So maybe I can even talk about this briefly now. But look, there's a math library. And the math library has many interesting mathematical functions. So you just import it. I always like to import something using a namespace, right? So that means if I have a function, for example, in init, I have a function called square. And in math, I have a function dot square. I would like to be clear in my head which function I'm using. So I import it. So here it will be m dot square will mean I'm using the function square from the math import. Okay. So it's a nice pattern to import with a namespace. So you can start using this now. We will start from this session on, we will start exploring various libraries. So this is a good place for us to think about imports. By the way, in your lab, all the test code that we write will import the code that you've written in your source files. Again, I would say simply that importing in general is a fairly profound topic. So this is just the baby introduction to imports, right? So just use this and get started, okay? Quickly, any questions on imports? Otherwise, I will go to one nice topic for today. Okay, the chat screen doesn't want to scroll. Okay, no questions, okay. By the way, for you who are typing in chat, if you say yes and no, I don't know which question, right? So please give me one more word of something, no questions or no questions on import or something. I don't know what is yes and no, okay? So add another word at least. Okay, so now we come to a very important topic. I cannot spend enough time on this, but at least it's a topic that you should spend some time reflecting on, which is very often in our programs, and this will become very, very relevant when we start doing more data science-y things. So I will use this idea again. So it's not just a cool thing I'm showing you. Very often in our programs, we will need to understand random behavior and we will need to produce random behavior. Okay. So for example, I've given you an example in my code where, first of all, let's do this where we want to flip a coin. Okay. So if I want to flip a coin in a program, how do I do that? Right. Now I will make a profound comment. How do we create random numbers on a computer? That becomes a whole subject. And I will make a statement here that will take a little time to appreciate. We cannot create random numbers on a computer, at least not by writing a program. Does everybody see that? Okay, this I would love to see what your response is. Do you think we can write a program to create random numbers? I'm watching chat. Someone. Maybe some of the advanced programmers. Can we write a program to create random numbers? I don't think they're ever truly random. And why would that be the case? This is correct. Why would that be the case? Why can't we write it? Can anyone give me a one-line answer why we can't write a random generator? Just we didn't try hard enough or what? Or we're not clever enough? Someone? I'm waiting. I don't, because actually, no. So, okay, we'll get into the discussion of how random number generators may be written, but let me give you the philosophical and important idea, okay? The idea is this. If you write a program to create random numbers, so we don't store random numbers somewhere and we pull them out. We want to create. So you ask this program, give me a new number, and it gives a new random number. The idea is that if you write a program, it means there's a rule. Whatever that rule may be, it's still a rule. And if there's a rule, then it's not random. Does it make sense? It's kind of a self-referential problem, but it's very important for us to understand. If there is a program that produces random numbers, it's a program. The program is deterministic. It's not random. And no deterministic thing can produce randomness. Okay. So this topic, even though I said to you, please go for a walk and think about this. Where does randomness come from? Why does it exist in nature? And why, as programmers, is it impossible for us to create it? And therefore, what do we do? In lieu of creating true randomness, we create things called pseudo-randomness. And what makes pseudo-randomness pseudo-random? Okay. And the answer is, of course, because it comes from a rule. Okay. Then we can ask the question: is it really random? Is it better? Is there a notion of better randomness and so on? It becomes a whole topic in computer science. For those who like algorithms, we can have discussions. I had to spend a lot of time. Just by the way, it's not just for making games. Okay. I'll just give you a wonderful example of random numbers. Those who are data science minded or finance minded will appreciate. For example, when I was working as a quant, one of the algorithms I used to evaluate the price of options, especially complex options, is a Monte Carlo algorithm. But the Monte Carlo algorithm requires us to generate random numbers. And it's, just to give you an example, if the random number generator is not good, the price of my options are not correct in some ways. So a lot of beautiful examples are there. I cannot get into all of them, but I just want to pique your interest, especially for those who are mildly advanced. Okay, there's no limit to how much you can explore in any of those directions. But anyway, having said all these beautiful things about random numbers, let's just go ahead and pretend that Python has a good random number generator, and let's just start using it. And there's plenty of fun to be had by just using it. Okay, so how do we use it? For example, you import the random number generators using this import statement. You can set a count. I want 100 random numbers. I can create a list, and then I can loop through. There are other patterns for creating this. I've just shown you the for loop because we just learned for loops. You can loop through, and the important call is here, r.randint. Randint will give me integer random numbers in the range 0 and between inclusive, 0 and 1 inclusive. Okay, just pay attention when you write this code. Is it inclusive or not? Okay, so this will give me zeros and ones. Okay, and now you can start doing all kinds of interesting things. For example, if it's a real random number generator and I generated 100 values, 50 of them must be 0 and 50 of them must be 1. So for example, see, this is where I said programming, there are lots of clever tricks you can use. I don't know if you like this particular trick. For example, to count how many random numbers have the value 1, I could just sum all of them. And because they are zeros and ones, the zeros will not contribute to the sum. So the sum will actually give me the count of ones. And so if I want to find the percentage of ones, I just take the number of ones and divide by the length of the random numbers. So you see in 2 lines, and this is the kind of code that I would love to share, but until you come up with the problem and you write it and you try to do it in your own way, you may or may not appreciate that I could calculate the statistics of my random number generator in 1 line really, right? So you can run this code and you can play around with the statistics. And I just want to show you that if you run this code, the number of ones is 51% and the number of, I should have changed my, this should be number of zeros, okay? The number of zeros is 49%. So whatever, each time you do it, notice the number changes, but of course that's because it's a random number generator. So there's plenty to explore here. Please play around with it. If you have questions, let's discuss. Even send me an email because these topics are big. Okay, so the next practical thing is, okay, I got zeros and ones. If I want to convert it into heads and tails and simulate some coin flips, then I've shown you a little piece of code. Can you please, all of you, I won't walk through this code. Please go through and read it. And if I'm skipping over any code, it's because I feel there's more interesting material we can get to and so on. But if anyone's feeling like, hey, I wish he would spend more time on this, please, let's do it in office hours. Let's do it through email, whatever. But don't feel like I'm not getting enough time on something, okay? And of course, interrupt me anytime on chat and I will go back and cover something, okay? But this coin flip simulation is pretty nice, okay? And all I want to say here is, look, you're already at a place where you start to understand randomness. You can simulate coin flips. You can understand if I'm betting on a coin, how to place bets. There's various things that you can do. It's up to you to create interesting questions and start writing code for all of it. Some of it I will help you to do. Now, I just want to show you one quick demo just to show you that we can do some really cool things. So for example, many of you might have heard of a random walk and maybe never seen one. I don't know. Let me ask on chat while this demo is running. Has any of you seen a random walk? Anyone on chat? I've never seen it, okay? So you can write a little program here. You see, this is a program that shows, the object on the screen going on a random walk. Okay, and the code to write this is fairly easy to write, but at least you've seen it now, right? And you can write this kind of code. Notice one thing, for those who are interested in finance, you can go and compare this with the chart of the stock prices at the end of the day or something, or during the day. And ask yourself, do you see similar patterns? If you go to Google Finance or you go to some website which has stock prices on it, just download the price of your favorite company or something and look at it. Okay, and tell me later and we can have a profound discussion, does it look random or not? Okay. And this is a very foundational element also of statistics. Random walks and studying random walks and behavior of random walks is a foundational subject in statistics. So I've just shown you in a couple of, in a quick demo that a lot is possible. They're all specialized applications. So anyway, let me ask a question. Can all of you quickly take this poll? I just want to know if you guys are interested in these kind of visualizations. Can you take the poll? I'll give you another 10 seconds. I'll say I'm interested. I've always been fascinated by visualizing things. I couldn't do it for a long time until I learned to program in Python. Or at least it was very hard, right? I had to use some complicated graphics package and all that stuff. Now we can do it fairly easily. Okay, so let me see what you've said. Okay, very interested. Okay, kind of split. I only got 8 responses. Can the rest of you click the button, please? I would love to know. Okay, I will come back and look at the stats later. But let me just continue on. So we're getting to the end of this section. Okay, now we can go to the magic 8 ball. And okay, I will ask the question. Do you want me to show you the code and talk about it, or you're going to just read it and figure it out yourself? Anyone? Talk about it, please. Okay. Okay. So I will change the font in a second. So I'm talking about it now because somebody said so, but I want all of you to really enjoy this little piece of code. Okay. You will think that when you saw the functionality that I showed you, you would think that, oh my God, that should be a little complicated. It's going to take a little bit of code. I have to have all these messages and random numbers, and how difficult is it going to be? So I want all of you to write your own version of this, but I will show you my version. So first I import the random number generator and I store all these responses in a list. Okay. And you can see, I would love for you to take this guy and customize the messages. So you can use it in your classroom or in your house or with your friends, make some fun messages for yourself, right? What is important is that it's a list. Each element is a distinct message. Therefore it has a corresponding index. Okay, that's all. That's how I'm using this data structure. Actually, I'm not going to mutate this list in this program. So it's really nice. In some sense, it's why I wrote it with capital letters to remind myself that it's a constant. That's kind of a coding convention. But anyway, so here's my list. And if all of you paid attention, when I talked about while loops, I said that if I want to interact with a user and perform an action an indeterminate number of times, a while loop is the right thing to use. So I decided to write my code with a while loop, but I need to know when to stop the while loop. So I'm going to ask the user, do you want help with a decision? When the user says no, then I'm going to stop. When the user says yes, I'm going to continue. And so I wrote a little function that is responsible to talk to the user. So it says, would you like help with a decision? Please enter yes or no. And then I've written, remember we had this bug in our Boolean logic code. I'm converting the string y to true. I'm converting the string n to false, right? So I have my converter built in. I'm also checking that if you don't enter y or yes, y or no, like this, then I am catching it in an else thing, and I'm going back to the user and saying, I don't understand what you entered. So please, this is a nice little pattern. There's some tricks in here. So please play with this. But you see now I can just completely close this off and say all my code is about writing a while loop. Somebody will decide when it's time to stop, in this case, the user. This function will tell me whether to stop or not. So if this function says continue, then all I have to do is create a random number. And this random number has to take a value which lies in the range of the indexes of my list. So it goes from 0 to the length of the list, -1, right? So the random number will generate a value. So for example, if I have 10 responses, the random number will lie between 0 and 9. Then all I have to do is really just index the list with the random number I got, right? That will give me, that will pull out the correct message. And I just, because it's a string that's ready to print, I just print it, right? And then when you're done, when you exit the while loop and you say, I'm done, I just print a message at the end, which says, glad to help with the decision, come back soon. And that's it, right? So if I actually count the lines of code, it's like 30, 40 lines of code, but a major chunk of it is just this responses widget, right? So even the actual line of code may be just 20, 25 lines of code. And I can make it even shorter, but I think that's just to illustrate to you the power of what we can start doing right now. Let me quickly pause. Give me some comments, couple of comments on the code and the application. Interesting, code looks neat. Tell me something, especially those who are advanced. You can make some comment about the code. Are you there? I don't see it on chat. Sorry. Anyone? Was it an interesting example? I need some inputs, quick. Okay, looks interesting. That's all I need. Yeah. Okay. But yes, immediately when you see a piece of code like this, realize that you can use it in many other settings, not just for building an 8-ball, right? You can build that particular code can allow you to build all kinds of interactive programs. Ask the user for something, simulate some behavior, blah, blah, blah. So I've just given you food for thought and a nudge to go and write all these interesting programs. Please write them, share them with me. You will learn much more by writing a lot of code and discussing it. Okay, so discuss with your friends, discuss with me, just keep doing. So now it's time to switch gears and go to the next. So now I can go a little bit faster because I can say, okay, the patterns that we're going to use are going to be very similar. And even some of this can be mildly reading assignments for you and coding assignments for you. So I will just highlight some key features. Please, I am watching chat. So at any point, I don't want any of you to say, hey, he rushed through stuff and I got left behind. At any point, I want to hold all of you responsible to stop me and say, I need, like somebody said, let's go through the magic 8-ball. Because one person said it, I went through it, okay? So, and of course, if more of you don't want me to go through it, just put a few messages and I'll look at chat carefully, okay? And if I still don't see your message, open your microphone and let me know. Okay, I want this to be adapted to what you want to see. Okay, so dictionaries. So dictionaries, I cannot stress, are very, very powerful. I don't know if I had to choose between a world which had only lists and only dictionaries, I don't know which one I would choose. I think I want both of them. Dictionaries are very useful and very powerful because they are associative. And accessing data by association is a very natural pattern, right? You give me the name of a person, I want to find his age. You give me the ID of a student, I want to find his grade. You give me whatever, give me X, I want to find Y, right? So associative access, as opposed to index, right? Index does not have any associative context. It's just a number that has not much meaning. But the dictionary is associative. So the keys have meaning and the values have meaning and we can associate them. So they're very, very powerful, and in some sense, they have become a standard in which we store data, right? Which is kind of interesting. There's a standard called JSON, which came from JavaScript. And again, like I said, if you ask me, I can tell you a lot of stuff about this. But for today, let me just say the following. Keys and values, that's what dictionaries are all about. And whenever you have an associative idea that you want to store, then it's very cool for us to use a dictionary. So what's the pattern then? So we understand this. And I've kind of said this here. So another thing is very interesting, right? If I have stored, so let me just say this because it takes a little while to appreciate how important this is. If I have a list and I have names of people in it, and I want to find the name of a particular person, if I say Andrew, find me the location of Andrew, then I have to iterate through the list, check every time if Andrew is there or not. And so it's going to become an order n operation for me, right? To go through the list and check every time and then find where it exists. But the dictionaries are not like that. They are actually, okay, so that becomes a detail. How do I build a dictionary? But dictionaries are optimized for me. As soon as you say Andrew, it has a order 1. So it typically can be an order n idea. You have to step through every element. That makes it order n if there are n elements in a list. But a dictionary will give order 1 access directly to the key that I'm searching for. Okay. So I think it's very cool for us to use dictionaries. It'll also make your code much more performant. Okay. Okay. So maybe but what do we pay as a compromise for this? What we pay is a heavy price. There is no natural ordered notion of iteration. And this can be a source of many bugs where you try to iterate through a dictionary, assuming that there's a fixed order. And that's a bad pattern, right? Technically, the contract with the dictionary is store my information in an associative way, keys to values, But dictionary makes no guarantees that the values will be stored in the order I inserted them or created them or anything. And assuming any kind of order on the values like a list would do is a bad assumption and can break. So just take some time to think about it, because once we learn lists very heavily, we make assumptions of order, which lists have naturally. There's an order in a list. Dictionaries have no natural order. And giving up that kind of sequential order is a big give up for us. So it takes a little time in your program. Again, I'm saying abstract stuff. It takes a little time in your programming evolution to give up order and translate it for association. And say, whatever I can do by order, I can do by association. Of course, if I want to go through a dictionary and do something for all elements in a dictionary, I will have to walk through all the elements in a dictionary. The only point I would make is, while you walk through all the elements in a dictionary, you cannot assume they arrive in any order. Your code cannot assume it. And once you do this, you become a master of using dictionaries. Okay. So as always, we'll just look through some simple things. I think the simple questions we must ask is, first, how do I create a dictionary? And the idea is that a dictionary, okay, it turns out that all these collections have many different ways to create them. My recommendation to all of you would be definitely learn one, maybe learn a couple. If you can learn more, then do learn all of them, but you can start using one of them preferentially, okay? But take a minute to get used to different ways of creating collections. So here's the dictionary that I have created here. You can see, by the way, this is a silly little demo, but I will ask all of you to please think about this interesting question. There is the number 1, and then there's the English form of it, O-N-E, right? So that's a beautiful example of an association, right? That this symbol 1 and this string 1 are associated. So by the way, in many programs, it's, I was talking to a librarian recently and he was trying to solve this problem. He was trying to convert, searches where people are searching for stuff where they enter integers and they want to search using the string representation. So it's a nice little program to write. How can I convert 101 into 101? And in those kind of associative problems, a dictionary can be very useful. So here, for example, I can go from the string 1 to its integer representation using a dictionary. So let's just do this. So first I can create a dictionary and print it. By the way, if you want me to run any demo, please let me know. Okay, otherwise I will just talk you through it. Can I just make that contract with all of you? There's a little bit of code to go through, but it's not very deep. Can I just talk you through it and not run it? Can somebody tell me on chat? Okay. So I don't want you to fall asleep, okay? So if I'm talking about it, maybe you can type and run it or whatever. To run it, again, just go to main.py and you can just run it from here, or you can copy it or various things. Or use the import and then just reference it. Okay, so let me continue. So one way to do it is use the curly bracket and you type the key : value, okay? And I want to say something here again, like I said for lists. It would be nice if all the values are of the same type, because when you pull it out, you know what to do with it. But there is no restriction on the dictionary, just like there is no restriction on the list for what the type of the values needs to be, right? So you could put the first value to be a number, the second value to be a float, like you could do 2.5 here and so on, okay? Just a programmer's tip, typically don't mix up all the types, and that will just make your life a little harder, okay? So there's no restriction on the values. What about on the keys? Okay, and the restriction, I put one quiz question in there. Why don't you guys try to use the power of the internet and try to understand what are the restrictions on the keys? And I would really be pleased if one of you would either email me or in the next class or in the office hours, ask me this question: what is the restriction on the keys? So rather than giving the answer, I'm telling you, please understand what is the restriction on the keys. It is complicated. Okay, so then the next one is to create a dictionary. You can also do this, right? But I want to call your attention to something very, very delicate here. The idea is this. Remember last time we talked about keywords? In this call to the dictionary, one is used like a keyword. So there's no string around it. You see, there's no string around it, but the dictionary constructor knows the first value is a key and it's going to make a string out of it. Okay, so you can actually run this code and it will work. It's a little, it looks nice to type, to write it, but then you have to really understand how does it work. Okay, so please play with this, put quotes around it, try to understand what's going on. Okay, so you can create a dictionary by just calling the dict constructor this way. You can create a dictionary. This is a very nice standard pattern we have. You can create a dictionary from a list of pairs. We will discuss this a little bit later. These kind of pairs, where I notice I use a different kind of bracket here. They are called tuples, and we will talk about tuples if I get through dictionaries, okay? But you can create them from a list of pairs or a list of tuples just by calling dict on it, okay? And then the last one is like a build-up pattern. You initialize the dictionary by just using the curly flower brackets, and then you index the dictionary. Notice when you index a dictionary, you index by the key, not by the integer. Whatever key you want to use in your dictionary, you index the dictionary by the key and assign a value. And this way you can build up your dictionary. Okay, so there are 3 or 4 different patterns I've given you. The next question you must ask is, how do I get something out of a dictionary now that I put it in? And the idea is you just use the key and it'll give you the value. Okay, the next question I guess is, how do I iterate? And here it's interesting, right? Enumerate, in the case of a list, enumerate gave you an index and a value. When you do enumerate on a dictionary, you get a key and a value. Okay, so again, use this pattern. This is a very cool pattern. We don't want to use it generally. You want to leave it in leave stuff in a dictionary and use the dictionary to access through keyed access. But sometimes when you want to do something for all elements, especially in initial programming classes and tests, there are many cases where they want you to pull everything out and do something. So enumerate is a powerful pattern here. Okay, if you just need all the keys separately and all the values separately, you can just use these 2 methods to get all the keys and all the values. And if you want to check if a key exists, you can check has key. Okay, so again, in one nutshell, I've given you this. Make your own file, try it out. It's good to have these patterns completely done. Okay, and at some point, I guess it's okay to keep the documentation with you and switch to documentation. But if you have a chance, we can go. Okay, quick question then. I have a nice little program here. If you tell me that you would like me to talk you through it, okay, you know what? I'll just do it. I won't make you type in chat. So the program is actually very interesting, right? I'm asking a question. By the way, I will give a clue to all of you now. Some of the ideas in this I have used in the lab to do a very fun program. Okay, so let me just talk about what's the idea. I have a sentence here, and it has a string which has kind of, it has words in it separated by spaces. That's the structure of the input. And I want to count the letters. Notice I say I want to count the letters, not the number of words. So what do you think? Easy code to write? Okay, since everybody's not talking, I will keep that as a rhetorical question. So you should try to write this code, okay? But don't get mesmerized by my solution. Write it the way you would write it and we can discuss your choices, okay? But let me show you how I would like to write this code, okay? So notice what I do is I take the string, I initialize the dictionary, and then I iterate through the string. So this is one thing we will cover next time when we talk about strings. But just like you iterate through a list, a string is also iterable. So I can go through the string. If I do for s in string, it will return me the letters one by one. Okay. Then all I do is I check if the letter is already in my dictionary. If it's already in my dictionary, I just increment the count by 1. If it's not in my dictionary, I insert it and set the count to 1. And then I'm done. Right? So these are, the programmer's equivalent of idioms, right? Patterns. Simple patterns, you'll find this a very useful. There's a counting pattern on any piece of input data, right? And it helps us to look at frequency of occurrences. Right? So for example, now I can, if this was really so, these little examples put us on the tip of, a very interesting field where in programs, we analyze the structure of languages in order to create language-based interactions with people, right? And in those kind of analysis, understanding the frequency of occurrences, etc., is a very powerful idea. So again, play with it, run it, write your code. I've not imported it, so you have to just import the solution and run it or whatever. I've given you a nice starting point. Quickly tell me, was that an interesting program? Would you have written it the same way? Would you have used a dictionary? At least tell me, would you have used a dictionary to solve this problem? Anyone? I would love to see what everyone's doing, because I would jump on the keyboard quicker. Okay. Okay, yes. So that's exactly, I think, this is exactly the pattern I want to create for all of you, right? That when you go to solve problems, there are many ways to solve them, and understanding these data structures allows us to write some very elegant code and distill some patterns. So there are some nice counting patterns associated with the dictionary. Okay, I've also given you a lab to do, so please go ahead and do it. Okay, I'm about to wind up the class. I just want to make a quick comment about tuples. So, and I don't, it's very, very short what I want to say. A list is an ordered collection whose length is allowed to change. A tuple is an ordered collection whose length is not allowed to change. But a tuple is a collection in which, because the length is not allowed to change, you can associate some meaning to each location. So you can say in the first location, I'm going to store a number, an integer. Second location, I'm going to store a string. And the string is the English representation of the word one. In the next location, I'm going to store, so it's almost like a row in an Excel spreadsheet or in a database table. But the row is not allowed to grow and shrink. It's kind of set. So whenever you want to model data, where in the list the size is going to fluctuate, here you model data where the length is held fixed. Okay, so that's the whole idea behind tuples. Just go through the examples, etc. But I know time is up, so I can take a couple of questions, but then I will switch quickly to a review. Any questions? Okay, so quickly, there's a poll in the summary. Can all of you click on it? We covered a lot of material today. So while I'm talking, you can all quickly take this poll, please. We covered a lot of material today, and it'll take a little time for you to, analyze and absorb all of it. So please write the code. The labs are very important. I will just flash the lab up on screen for those. I don't know. So let me see what you guys said. Okay, so while I wait for the poll to come back, what I wanted to say is here, I'm just showing you this lab on the screen. It's on the lab section in the program, in the course material. All the instructions for the lab. Okay, so let me just, since I'm here, let me just show you where the lab is. I don't plan to go through it. I can discuss the lab in detail in the office hours. By the way, not many of you go to office hours. Is that a standard practice, or you get an instructor for free to spend time with you talking about anything you want? I would have taken that option, but okay. So here's the lab. So if you click on this, so I hope you're all following on the screen. If you click on this programming lab here, it should bring you all, I've written fairly detailed instructions for what to do. And in here is the actual lab code. And if you click on it, you can just go in and work on it, okay? So please spend some time. If you have questions, come back. I don't want to hold you guys longer. I will give you a couple of minutes. Do you have any questions right now that you want to ask anyone? You can unmute your microphones and ask quickly. Anyone with a question? You're all very, yes? Yes. No. Okay, so most of you may be okay. I know we're running short on time. I will do office hours on Monday. If you guys want to talk, then we can do that too. So I will. I hope all of you have a nice weekend and stay warm. And we'll talk again on Monday and/or next Friday. In the meantime, if there are any questions, send me emails. Okay. Thank you.
Okay, thank you.
Thank you. Ame, you're still there?
Yes, yes.
Yes. I will call you in a minute. Maybe we can talk for a second.
Okay.
Okay. Okay.